And there we go. So the first part of the project is project 2A, and this is basically like 1A, except you're going to be doing just a little bit more this time. So what you can do is copy as much as you want from 1A for 2A. You could basically just take your result from 1A and make it as like your starting code. Or you can start from the code fragment that they give you and copy paste bits from 1A as you like. That's what I would recommend, because otherwise you're going to get kind of confused with what you need to what you need to keep the same from 1A to 2A. But in 2A you are adding symbols, and you are adding, I should use the other one. Is this the right? Oh, here we go. Yeah, look at this. So you're going to be adding global variables, which are your symbols, and that's going to be, I'm going to try to keep that consistently in red here, not at the bottom, ignore that. And you're adding relocation, which is your green. So you're going to be turning your assembly code into object files. And the white and blue, your text and data, are going to look exactly the same as they would in your assembly, but you're going to be adding these symbols and relooks at the end. So you will always create a symbol if you come across a label that starts with a capital letter. So it starts with capital letters. And you are always going to add a relocation if you are using a symbol in one of your instructions, in your load word, your store word, or your .fill. You do not have to do it for BEQ, because that is just based off of offset and not based off of an actual address. So this is going to allow you to compile all these different pieces of code together and turn multiple .as files into a single machine code file. Does that make sense to everybody?
I have a hot question.
Okay, cool.
So you mentioned if a label started with a capital letter, it'd be put into the symbol table.
Yes.
But then you also mentioned like for other labels as well, it's put into the relocation table. So what happens if you have like a label with a capital letter? Would it be put in both the symbol and the relocation, or just the symbol?
Yep. So it would be put in both. Over here we have 5, which is not capitalized, but is used as an argument. So it goes in the relocation table, and then beneath it in yellow is the subaddress, which is both capital and used as a argument. So it will go both into your symbol table and your relocation table.
All right. Okay. Thank you.
Yeah, ask questions. I'm much better at answering questions than lecturing or anything like that. So in order to make your lines for the symbols, whenever you save them, you can just basically use this flowchart that I tried to put together. So if it starts with capitals, then you know it's a symbol. If you are using it as a label, so in your first loop through all of the lines, then if you find it in the text section, you're going to do its name, and then a T, and then whichever line it's on. If you find it in the data section, the name, then a D, and then whatever line it's on. If you find it as an argument, you're going to add it to your list of symbols with the name, a U for undefined, and then the line should actually be 0. So I'll write that real quick. This should be a 0. Lost track of what I was thinking. Little brother walked in. So if you're adding an undefined to your symbol list and it's already in there because of a T or D, then you can just ignore it. You only want the symbol in your list once each time. So if you defined subaddress in here at some point, then you would only have like subaddress D10, for example, if it were on line 10. So that's how symbols are roughly going to work. For your relocation, if it is used as an argument, you put it in the relocation table. It feels more complicated because when you get into the linker, you have to do different stuff with it. But if you use it as an argument, it goes in the relocation. And it's going to be the offset and the instruction and the name. The offset is how many lines in it is from the start of that section. So not of the entire file, just like either the data section or the test section. And then the instruction is whichever instruction is calling that label. So for 0 load word 5, it's saying that the 5 is being used for a load word 0 lines into the text section. So how's that? Does that make sense for everybody?
I had a quick
I have a
question.
question.
Okay.
All right. Oh, okay. So for the symbol and relocation tables they should be in the order that they're observed, right?
It does
Or
not
is it
matter the order.
doesn't matter. Okay, thank you.
Yep.
When you say used as an argument, does that just mean like when it's used as a symbolic?
Yes. Yeah. When it's used as the offset value for LW, SW, and .fill.
Okay.
I have a quick question too. I don't know if I misunderstood you, but you said like if it's already used as a label, then like you can't, like for example, if you want to use it as an argument but it's already defined as a label, then you would have to remove it as a label and then
Right. So you
put it
only
in as
want,
an argument.
kind of like the other way. You only want symbols in your symbol table once each. So the first time you go through it, you're going to put them all in as labels. And if you come across the same global label as you're going through the offset values, you don't want to add it to your list. It is already in there, and you don't want to re-add it. So if we had our, oh geez, that is small. You can kind of see that. If we're defining our subaddress down here, and the first time we loop through, we're going to come across that, and we're going to add subaddress as data in line 8, something like that. And then the second time you go through, you're going to come across subaddress again in the as an offset value this time. You're not going to want to add it to your list. It is already there. So you're going to want to double check to make sure that it's not already in the list so that you don't add it twice. Does that make sense?
I understand that part. I'm just questioning like, would you have to change like the letter from like D to U or like T to U?
Mm-mm. D will be more useful. So
Okay.
you want, yeah. The D and T are more important than the U.
All right.
And if you come across it twice as being defined as a label, then that's an error, and you throw that and you say, hey, that's not cool. So if it's being defined twice, then that's an error, and that's bad. Okay. Does this make sense to everybody so far? Does everybody have an idea of what a symbol is and what relocation is? Or at least how you would put them in their tables? Okay, I'm not hearing complaints. I feel like Beaumont. Let's pop down
Yeah,
to
I think we're good.
Okay, thank
There's
you.
nobody asking.
It feels very weird on this side. I'm just going to let you know.
I can create a temporary text thread just for people, like for like yes and no's and stuff like that. So
That
we
would
don't
be-
wait in.
Sure,
Okay.
that works totally fine. I remember.
I think we're all just being quiet because we didn't want to like say like, oh yeah, we understand it, and like somebody else doesn't
Okay.
feel like asking a question.
Great. It's a thread at the very bottom of the text channels, right above life after 370. So just like if we're all good, just say like yes, 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 and then I'll just let Brighton know if we need to move on.
Good. Okay, cool. I'll try to like check that a lot. Yeah, because the first time we did this for like project 1, there were only like 3 people, so one person could keep on asking me questions, and a lot more than 3 people came, which is awesome. I like many people. Thank you.
I hope you like people.
How many people now? Ooh.
Yeah, we have a lot.
Okay.
All
Cool.
right, we can move on to the next section. I think people
Yep.
are good.
Okay. And then at the bottom is like how I planned out each portion of the program. In the end, each of these squares is like a loop that I executed. So I did one loop for saving all labels, and then one loop for all these 4 things, and one loop for this. So they're put together. So that's all in the announcements channel, I think, or the links and resources where you can check out these slides for yourself. So here is the linker. And this, I would say, is the trickiest of all 3 parts in understanding what it's actually doing. So we're going to go through it maybe a bit slower and try to understand everything that's going on. But essentially, for the linker, you're going to be going through all of the relocations that you just created in the new assembler and modifying your text and data lines to match those relocation lines. And in the end, you're going to be compiling. I did the same thing as him. You're going to be linking more than one assembly file into a single machine code file so that you can run that as you normally would. So you're going to go through each relocation file. If the variable that you get, I should probably draw out an example relocation, which we'll use our, no, it's right down here, 0 LW 5. That's some nice handwriting. You're going to go through this, and first you're going to check if it is a local variable or a global variable. And because it starts with a lowercase letter, you know that it's a local label. Then you're going to check if it is a text or data. So that's interesting because it doesn't depend on this. This is which function called this local variable. You actually need to find the line that this number refers to and get the offset value from that. So because we know that this is an LW, we know that this must be text. So we go to the 0th line of text, which happens to be this right down here, and we can bitmask that with 000FFFF as a hex value, and that will give us our offset value. Then you need to compare that to the number of lines of text in for that file. So for this specific file, there were 6 total lines of text right over here. So if it is less than 6, then you know it must be referring to a text. I'm starting to lose track of what's going on here. There's a lot going on, so it's totally fine. We're going to go through this a couple times. If the offset value that you get from the line is less than the total number of text lines, then you know that you must be getting, you must be referring to text. If it is greater than or equal to, then you must be referring to an address in data. In this case, our offset value is 6, which is greater than or equal to the total number of text lines, which is also 6. So we know that we are referencing a line in data. Does that make any sense whatsoever? It was a lot of gibberish.
I understand, like, if the offset value is less than the number of lines, then it must be text, and greater than you're in data. Could you go over how you're calculating the offset value and like where you're getting those numbers from again?
Mm-hmm.
I was a little bit confused about, you said like 0, so isn't that like line 0, which is, I guess that's where I'm getting a little bit confused about.
Right. Okay. I think I did go a few steps like beyond where I should have. So this 0 right here has to be referring to 0 lines after either text or data. And we know that it is text. Okay, gonna step a few steps back. Let's get blue. These 2 lines right here refer to which line referenced 5. So we can use these to get the original line that called 5 in the first place. So we know that because it is LW, it must be text. So we would go to the 0th line of text and get 8, 4, 5, 4, 1, So the first time we ran through the assembler, it took this line and turned it into, okay, not blue on blue. It took this first line and turned it into this first line of machine code.
Mm-hmm.
So now we have this first line of machine code, and because it ran that, because we created this piece of machine code exactly the same as we did in the assembler, we know that the last 16 bits must be our offset value, and we want that offset value. So to get the offset value, we just have to bit mask for those last 16 bits, which we can do by ANDing with 0x0000FFFF, because that's just the last 16 bits. And then that will give us our offset value.
Okay.
The offset value is the line that has that label 5.
Oh, so it's kind of like in Project 1A when we were storing like where each label is, basically.
Mm-hmm.
Okay.
Right. So we're storing all those labels where they are exactly the same as in Project 1. I think that all of these lines are exactly the same as Project 1. There is a special case, and I'm going to get to that in just a bit because I don't want to be confusing. But for the most part, these machine code lines in your object file are going to look exactly the same as they would have in Project 1.
Okay. Understood.
Okay, awesome. Once you get that offset value, you can determine whether or not this line was referring to something in the text section or the data section. Because the offset value is 6, you can determine that it was referring to something in the data section. And then you will follow down that path for modifying this line in order to get the final thing that you're going to send to the final machine code file. So in this case, we know that it is data. So the first thing that we're going to do is subtract the text size from the line. This is a little bit weird. I could probably explain why this is, but for now we're just going to go through these steps so we get our final result. It's right down here. So the total number of text lines in this file is 6. You're going to subtract 6 in order to get this like intermediary number. And then you're going to add the start of the data in your final answer. I wish I'd copied over the final result that they gave in the specs. But essentially you're going to have your text from file 1, F1, and your text from file 2. And then you're going to just concatenate these all together. You're going to have your data from file 1 and your data from file 2. The data starting line is referring to the first line of the new like machine code file that you're creating that refers to that file. So this, I think, would be 6 plus 3. So this would be this would be line number 9. And that is why we are adding 9 to our machine code line. And then this is our final result that we're going to be outputting to our machine code line. How's that?
Wait, why did we minus 6 again?
We minus 6, so I gotta make sure this was kind of weird. It was because when you created this line in the assembler, you did it exactly the same as your 1A assembler did, and that included adding all of these 6 lines as part of your text file, or as part of your text lines. So these 6 lines, and then you were on line 6. So you added that to your final result, and that gave you your number as you did in 1A. But in order to get your data starting line, you're actually adding those 6 lines again. They're right here. So in order to make sure you don't add them twice, you're just going to subtract them once.
All right, so you're just basically you're just calculating a new offset value because you're
Yes.
compiling the two files together.
Yeah, I
right.
should probably try to speak more abstractly rather than like. But yeah, you're calculating the new offset value in the new line, or in the new machine code file that you're creating.
All right, gotcha.
Okay. Thank you for asking the question.
I hate to interject, but I just want to make sure on like a high level. So like basically we're just like altering the existing assembly, right? So that we
Yes.
like okay, I just want to make sure like I wasn't missing anything. Okay,
Yeah,
cool.
I should go over. Yeah, interject, please. Lots. I like it.
Okay.
Um, so essentially, the high level thing that you're doing here is you are taking the machine code for each of these different assembly files and you're putting them all together into a single big machine code that looks like this over here. And then you need to change all of the offset values so that they still point to the line that you wanted in the first place. So when we're referencing 5, it's no longer going to be pointing to 5 anymore after you insert this whole bit right in between them. Oh, that was off the screen, whoops. So then you just need to change that value so that it still points to the correct 5 label. With the global variables, that's why you have the symbol table. At the beginning, you're going to want to, I think I forgot to add this to my overview, which was a mistake. But at the beginning, before you run through all of the relocations, you want to go through each file's symbol table and like compile all of those into a single data structure of all of your symbols. So that later, when you have a reloc that points to a global variable, like over here the LW04 capital subaddress, you can just reference that big data structure that you have and find the position that that symbol is now at and add that to your line. I wanted to say something else, but I can't remember what it is. So I'm going to go back and tell you about the quick exception that happens that is not the same. This is the only thing that is not the same between your assembling these lines, the text and data, from 1A to 2A. And that is when you are referencing a global it's when you're referencing a global label. So when you're referencing a global label, essentially, you just pretend that the line is 0. So you do not add anything as your offset value to this line. It is just your instruction, your argument 0 and argument 1. That way, later on, you can just add the new offset value to that line without having to do any like subtractions or anything like that. You just add what line the global variable is now at to your machine code.
So we'd also like take out all our previous error checks for like whatever labels, like undefined labels. You would take out those error checks because it could be in a different file.
Right.
Right.
Only for the global variables, but yeah.
Right.
For your local variables, you still got to make sure that they're all defined within that .as file.
Gotcha.
All right, just checking something. So that's kind of the overview for the linker. You are going to be taking the lines from the object files, and based on all of the relocation lines, modifying them so that they now correctly point to the new location of that label.
So would you have to combine the object files first before doing all this math?
I think at the very end, I don't think it really matters too much which order you go in. At the very end, you can just go through each file and print out its text, and then go through each file again in a second loop and print out each data. And they have a whole bunch of, like, as part of their code fragment, they have a whole bunch of processing the inputted object files, so that you'll have data structures of your text lines and your data lines and your files and your symbols and relocation and all that. So So they'll kind of process everything beforehand. You're not really going to be combining each of the text files until you print them out at the end.
I guess my question is then, like, how would you know that the data starts at line 9 before combining the files then?
You can go through each file at the very beginning. That is step 1 down here. I believe this, hopefully this answers your question, but you're going to be going through each file, and you're basically going to have a running address. Starts at 0. You're going to go through each file for each file. You're going to set that file's starting text line to the address, and then add its text size, the number of lines for that file, to the address. So that will keep track of which line you're currently on. So you're going to start by setting the starting line for F1 to 0, and then you're going to add the number of lines. That's going to be 6, and then you're going to set the starting line for file 2's text as 6, and then add 3.
Okay.
They're going to have a pretty substantial struct that you can save all of this information to. The data starting line and data size and all that stuff. We'll just go into the struct and you can reference them all later.
Okay, cool.
Just for consistency.
Yippee for starter code.
10. Yay. Oh, and you can't forget this. You want to hold on to this address after you're done doing these loops, because at the very end, this is going to be 12. At the very end, you have to add stack. So you just create this. You just create this global label at the very end, and it should be at the very last address after you've accounted for all of the text and data. You're just going to add that stack symbol to your data structure, and you can reference it in any of the .as files, but you're not allowed to ever define it. That's not allowed. That would kind of break things. Okay.
I think we're all good on questions for this section. If anyone else has questions, you can ask now, but if not, write in if you want to move on to the...
Okay. I'm just
third
reading through all
page.
these, making sure I'm not missing any steps. Okay. Before we go on to the last one, feel free to just speak up, like, as a quick answer, but, like, how well are you understanding this? Is this getting really crystal clear, or are you getting, like, a muddy idea of what's going on here? Like, anybody speak up. Or use the chat. I'll go check that. Use the temp thread.
I'm feeling pretty good on, like, the general overview of, like, what we're supposed to be doing.
Okay. Thank you.
Yeah,
Yeah, same here.
Okay.
I think a lot of it will just come with like actually putting like actual code down for the linker part, but
for
getting
sure.
like a high level is like good so far.
Okay. Thank you. That sounds good. So this last bit is where you're going to be writing in more assembly. Yay! Who doesn't love writing in low level? Yay! And this time you're doing function calls, and they require that you do function calls, which is even more fun. You're going to be calculating some combinations of like NCR. This is going to be, I barely remember this part of EECS 203. Surely you guys know this better than I do. It's where, you know, you have n things. How many combinations of size r can you create for them? And I haven't been thinking about it like that because actually you could just do it using Pascal's triangle. This is what I prefer to focus on. So they're going to give you n, and n is going to be, you know, like whatever row you're on. So we'll say, oh, actually, yeah, 6 is fine. So n equals 6, and r equals 3. Then you essentially need to calculate this number on Pascal's triangle using a recursive function. So your function is going to have a base case first. You can do that by saying if r equals 0 or r equals n, then it must be on these outskirts right here. So you can just return 1. Otherwise, you're going to compute, what was it? C n minus 1 and r, which is this guy in this sense, or for that number, and n minus 1, r minus 1. I think I did this backwards, but that's okay. You're essentially computing the two numbers above it, and then adding them together and returning it. You're going to get your two arguments in registers 1 and 2, and you're going to be returning the value in register 3. And I have all the registers that you should use in the bottom right corner. That's also in the specs. So that's these down here. And essentially, adding two numbers is not very hard in LC2K. You do need to make sure you are storing and calling the correct registers, or storing and loading the correct registers and doing it in the correct format, so that you're not going to lose any of the registers as you're recursively calling the function. It's kind of tricky to think about this as an LC2K symbol, or at an LC2K level, function calling and that kind of thing. So it's good to think of it abstractly, and think when you're calling a function like it's going somewhere else. It's hard to explain this bit, but I spent a long time sitting there trying to think, wow, this is going to start the code all the way at the very beginning. It's going to have to somehow be different this time. So don't try to think of it like that.
What? So I'm oh, sorry. Go ahead. Finish.
Okay, I don't blame you for being confused. Go ahead and ask your question.
I'm just is this any different from BEQ then? Or I guess Jalar would just be okay, once we're done with this, we're just going back to the top of the loop. I guess I'm a little bit
right.
What's the difference between going back to the top of the loop versus using a function call?
Right. So you're gonna have your lines of code. I'm gonna draw some fake lines of code.
Beautiful.
I'm gonna say this is our Joller. Thank you so much. And then we actually have two Jollers this time because we're calling it twice. So this is my beautiful code down here. So you're gonna be going along. You're gonna come to the Joller, and it's going to send you back to the beginning of the code. Send code. I'm going to send you back to the beginning, but you have to remember where you left off, so that when you are returning, you don't go back to the beginning. You go back to the next line. So I'm going to be from there. I'm going to go from the end. You remember that you go to the next line, so that when you do this for the Joller, for the second Joller, you go to the line after that, and not the same line as before.
Okay.
So I guess whenever you call a Joller, definitely try to think of it as a different state. You're not running the same state over again. You are hopping to a new state of this code, and you have to, I don't know, have to what? What was that sentence going to be, Brighton? Anyway.
Wait, so you have to, I think you were going to say you have to save and
yes, that was it. Thank you.
Yeah.
Oh my gosh, good job. Okay. Yes, in these lines before and after, you want to make sure that you save. I found you only need to save registers 1, 2, 4, and 7 based on what they tell you over here. And then after you make these two function calls, you want to reload all of those registers again from your stack. So 5 is going to be keeping track of where you are in the stack. It's going to start at 0, and then you're going to save something that's going to go to 1. And you save another thing, 2, 3, 4. And you can just keep 5 constant throughout the entire thing, because it's always going to know which line of the stack you're on. And when you are loading stuff back, you're going to subtract each time you load something until you get back to where you started. Whenever you're loading and storing, it's going to be, just a load 5, and whatever you're storing here. So I don't know, let's just say number for register, and then stack your big old global variable that you can use for memory centering. I think this whole thing just boils down to like your function call, which is the loading and storing. So store the sum and load the sum, load some of them, and then your combination, which is just adding two numbers each time. It's kind of two separate pieces.
And we have to use recursion. Wait, like recursion.
So this is interesting. They
Aw.
have so many rules for how you have to correctly execute this, because apparently there are many easier ways to compute the combinations of things.
Yeah, there's like formulas.
Yeah. Oh yeah. So you do actually have to call. You do actually have to recursively execute things. You have to call every time, unless it's the base case. You have to call the function over again, and you have to load and store some registers. And you have to use registers 1, 2, 3, and 7 exactly as they say you should. So there's a lot of rules, but I guess it's also good for structure. So that'll be helpful. Once you get into, they also have a competition to see how fast you can make this go. I thought I was gonna be really frustrated at first because I thought there's no way you can speed this up with the number of rules. But for 2Z is what it's called, they actually remove a lot of those rules. So it really is about optimization and trying to come up with really clever ways to work around Pascal's triangle and cut out as many steps as possible. So that's 2Z. For 2C, you want to follow the rules and make it exactly as they say, even if it feels boring because it's assembly, whatever. And then 2Z is where you can think optionally about the puzzle and try to come up with clever ways to do it much faster.
So you're gonna get number 1?
I'm trying, but some people have some very, very small numbers already. In order to
Oh damn.
There's only like 2 people, and I think they're IAs too. It's not very nice. But in order to count,
Oh, that's cheating.
it is cheating. How dare they? So you have to do it in less than like, was it? No, it was 100,000 and something instructions total. They're going to give you the inputs, or you have to calculate 14 to 7. In order to count at all, you have to do it in less than like 100,000 instructions. Which, if you're doing everything exactly as they say in the rules, you're probably going to get 120,000, something like that, just a little bit over this. But yeah, they're at like 1,000 now, total instructions. And I'm trying to figure out how to beat that.
Well, I mean, without all the rules implemented, couldn't you just use like the combination formula, or does it still have to be a recursive call?
I don't remember. I think you can actually just do a formula. I think the only rule is that you can't use predetermined values for 2Z.
I was thinking about that.
I know. you just compute.
I was about to ask like how high do the combinations go? You can just hard code everything.
I mean, that would still be a lot of. Would it be 2 to the power? I guess like that would be a fine answer. You'd have 2 to the power of 16 or something. Oh no, it would be even less. You're right. If you couldn't just do if you could just do preloaded values, that would probably be a really efficient way of pulling that off. Yeah.
Or you just do preloaded values of all the factorials.
Yeah.
And then after that, you can just do the formula.
You can divide stuff.
Yeah. Oh, actually, yeah. Crap, dividing. Oh.
No, well, isn't dividing just reciprocal of multiplication?
Yeah. How'd you get the reciprocal?
Yeah.
Also,
wait, but then like a lot of it cancels out as well, right?
Right. So you could just do multiplication.
Yeah.
Yeah. So this is a fun puzzle. 2Z is much more fun than 2C, but 2C you just got to get through and get an answer, and then watch it get 100,000 instructions and make your Visual Studio almost crash when you screw it up and have 1 million instructions. Whoops. So does 2C make sense? It's a bit simpler than the others. It's just more fundamental.
Yeah.
Okay.
yeah. think we're good here. If you want to stop the recording, so
Okay.
then people don't listen to us ramble.
Oh yeah, damn it. People have heard us talk about hard coding.
Dang it. Whatever. All right. I think that's everything. Questions might be good to put in the video. If anybody has any questions for any of the parts, that'd be kind of constructive. Floor is open. Let me check the chat over here. Okay. All right. Then
Yeah,
I think.
I was just gonna say, like, I think a lot of people drop to do or like finish homework too.
Cool.
But yeah.
Okay. Then I will stop the recording.